Hey everyone! TMAC is a digital twins ecosystem that enables companies and enterprises to acquire real surfaces and fabrics to virtuality, and that helps the cut of the cost of the production of photoshoots of the products and also makes prototyping of new products faster and with less of the waste. So today we're going to take a look at this fabric and how it's going to get digitized with our newest software update. There's been some huge improvements on multiple fronts that will take over. I don't have a TMAC around here. The reason is because we've implemented a cloud integration. That means that anywhere the scanner is, that's where the surfaces are digitized. And then the location where they are processed, which you'll see is super minimal, can be remote and detached. So let's take a look on processing of this fabric. So before I start, I'm going to take a look on the computer and we're going to start processing. So there's a layover. So here we are on the computer and I'm going to simply click on this one fabric that is available to me. Now any fabrics that's been digitized are available in this gallery on the device wherever you are. So when I click it, the processing starts. And the processing means that the fabric is downloaded and that the actual files are being made. This process takes around 1 to 2 minutes. Meanwhile this is going on, I'm going to show you some of the actual inner workings of this fabric and why it's interesting and important to digitize this one. It has a very silky-like behavior, which you can see here. But it also does have a metallic knits and threads all around that again has some type of metal behavior to it. It of course has some relief as well. So I'm going to keep it here. Let's take a look here how it's being processed. So now that it has been processed, let's take a look on what we actually have. So this fabric's been split into 5, 6, or 7 descriptive layers. Now each layer is something you would not get with a flatbed scan because this fabric over here needs to be described in color, in roughness or mattness, in its relief. So what is the actual touch relief when you hover over, when you go over it. Also, we need to separate what is silk, what is metal, and therefore it's going to enable us with all those descriptive layers to basically have this sort of reliable digital twin for PBR workflows, but also for hybrid AI workflows. So when looking in here, this is the color that we've been able to get. Now take a look on the resolution here. We're using a 100 megapixel camera, so there's been a large upgrade on the sensor itself, and in the device we're actually already delivering files that are nearly flat. So both flattening and authoring are here only for a artistic basically purposes, but the actual texture and all the maps are flattened by themselves and are actually delta E below 0.5 on the color. So we can zoom in, we're going to see a tremendous amount of detail. That is for the albedo, which is the color description, but also for a normal map. So take a look at this. This is a normal map you cannot possibly get through any other method than through direct high resolution acquisition of a fabric. So each of the colors in here are representative of where the actual fibers are oriented and where's the light that they capture. So in this case, a silk is purple because it's oriented, like its hairs are basically brushed in one way, whereas these pyramids in here are oriented in another way. So that's going to capture again light differently, and it's very important that is perceived and correctly captured in the normal map. And then we do have, of course, roughness, basically that says, hey, the silk is matte, whereas the metallic threads are much more glossy. And then we do have metalness, which exactly splits the material into a insulator and a metallic. So all these fabrics together, they make up a material. High resolution, and basically the current application that we're looking at is fully undestructive. So any setting I'm gonna do in any of these paths, and even then coming to the 3D, which we currently have a early integration of Corona renderer, I can go back and tweak anything and see the changes directly throughout the pipeline. So that is a large, there is a large part of the software which is removing the friction of going from the actual app to 3D and redo and back, etc. So everything is in this application, end to end, from the scan till the final authored material. So what we're going to focus on right now with this version is really the tiling, which is minimal and is going to take us just a few minutes to get done in this resolution with the real-time non-destructive workflow. So first thing I'm going to do is try to identify where the tile is so I can see these triangles that are repeating. So I'm just going to grab it and I'm going to roughly put it in where it needs to be. Maybe let's take these big ones. I'm just gonna help myself jumping in here. So this one's gonna be there, this one's gonna be here, this one's gonna be here, and forth. Okay, so I don't need to be exactly perfect, even though it would save time, but I can jump already in tile, and what we do in this module is anyway super helpful, because we can project the actual projection on demand right away and see where it aligns or doesn't align. So this is very helpful, because in the end you really care about the end tile, not about like where it's placed in the source, right? So I kind of on purpose put it in the wrong location so that I can go, and now I can expand this one here, match the corner better. I can come here in this one, expand it just as well until I'm going to be getting a good kind of match. So I'm working with it, working until I'm getting something that's better. Okay, so now I'm getting roughly like with double and corner in here. So what I can do as well is just take the whole area and shift it until we meet somehow somewhere better. But what I can see already is that we've probably done a mistake on picking the triangle, because these two ones are not the ones. So I'm gonna shift over here, and that's the actual ones. So a few seconds, and we've nailed that. Now this is still not gonna be perfect, as you'll see. So we still do have some jumps that we would like to take away. And the other tool that we have here is actually straightening. So if I want to take a double look on this one, and that is being skewed just a bit, I can go ahead and I can make a line that I know that is definitely straight, which is coming from here, towards here, towards here, towards this one, and down again. Okay, right click. And now if I come back to the tile, this line is always forced to be straight. Now I can make any lines. I can make a line that is in here. I can make diagonal lines. There's no problem. It's always going to come and straighten or find the diagonal right angle to make everything correctly dewarped, basically. So if you have like a transparent fabric that it's somewhat, you know, like making waves and things like that, no worries, you do it, you click it, it's there right away. As you can see, this is basically a high resolution image that we're working on. It's it's a 12K image, so almost. So we're gonna be having no problems using as many lines as we want, and also that is because we're using a streaming type of method of working with these files. So anywhere I zoom, is actually giving me those pixels that I need rather than the whole thing at once. So super fast, super intuitive, also intuitive undo. So that one is in here. Let's take a look if that's correcting it, and it does. I can hold space to remove, and it did much better what I needed. So I'm gonna just take a look very swiftly, like whether there's some other lines. And what I'm gonna do is actually try to make like a line where I'm gonna just basically take that part. So I'm gonna come here, vertical. So once again, there you go. And once I come in here, I'm gonna take a look right on that point. Actually, I need to add it, so I'm gonna click edit point, and I'm gonna try to move it like this. So now I was able very quickly to retain the correct alignment of these points and correct that one. So okay, I'm gonna keep it there. Of course, when we do have tile currently, it's still noticeable because of the straight line. So we do have two tools for that, very quick to apply. One of them is what we call invisible path tiling. So basically, if I, let's say I'm gonna come here, you can define a window where a crooked line is gonna be searched for to not just tile based on lines, but it's gonna be based on a hidden path. So if I come here and I try to make the window bigger, it will right away see this sort of crooked line that is trying to hide this tiling. Now don't mind the actual gradient here, that's what we're going to do in just 1 second. But in here you can already see this line where it's taking its route, trying to basically make it much less visible. So if you look at it right now, it's much less visible than it's been before. This is going to be taken one step further with the actual blending of this line. So I'm going to take a look here and I'm going to blend it, and that's going to basically take it to almost finale, whereas like when we're blending we're losing a little bit of contrast, so you can push sharpen to resharpen and get it to where it needs to be. The good thing about this path, invisible path, is also that if I remove the blending and sharpening and we take a look on this path, let's just keep the most visible one for this, let's say normal, we can still tweak the corners or do any sort of adjustments that we need to, and it's going to recompute on demand throughout all 6-7 layers in the resolution that we're talking about. So now I'm going to go to flattening. That's just a helpful tool. So the silk, of course, like it has some sort of natural gradient. In one click, you can take that away in here. So let's take a look now on height. That needs just a bit of the flattening somewhere around here. Roughness is already good. Metalness needs a tiny bump. Opacity, translucency. Okay, and that's basically it. Now we've tiled and made the whole material, so all we need to do really is to go and export it. So I'm gonna go export, go new folder here. I'm gonna save. Meanwhile it's saving, you can start working on different materials, or you can already switch to 3D with the early integration with Corona and 3ds Max and try to get this material applied to the particular product of yours. So that would sum the current workflow up, and meanwhile this is rendering. Take a look on the samples provided that we do. We do have wonderful cameras from both from Sony and both from Fujifilm. We're using a Sony amazing industrial camera with master lenses, and Fuji is of course an amazing ecosystem too. So that's it, and thanks so much.